So here we have a hill. Now if we want to draw a contour map here, how will we draw this, right? So we have to find RL of different points. So these are RLs. As the height is increasing, the RL is increasing. What is RL? It is the reduced level. It is a distance from the mean sea level to the point under consideration. So 80 RL. So we are here. Okay. So along this line, what is the RL? 80. Along this line, what is the RL? It's 75. Along this line, it is 70. Along this line, it is 65. Like this. So if we draw this one is at the outer edge 60, then 65, then 70, then 75, then 80. So as we are going up, the RL is increasing and this size of the circle is reducing. So we have to know that this is a hill. Okay, so we see here, we see that 60-meter RL is on the outside, 65-meter RL is on the inner side, then 70, 75, and 80. So we have to know that the value of RL is increasing towards the middle. The ground is higher towards the middle. So therefore, it must be a hill. Okay. Then this is again the same type of example. Here we have these two hills are here. So if we draw, so here we will have like this because we have two RLs here. Okay, two peaks here, right? So this is the 3D one and this is 2D one. Okay, from here, if we are given the 2D version only, we have to know that, okay, here we have RL, higher RL, here we have higher RL, here we have little low, less RL value, again less RL value. So the ground is higher here and it's decreasing, RL is decreasing. The RL is increasing towards the middle. So again, we can find out, okay, these are two peaks. Here we have another peak. Like that, we have to carry out our assumption and studies. Then, like, this is a bigger map. So finally, an contour map may look like this one. Okay. So from here, we have to find out, okay, where is the ground is higher, where the ground is lower. Very easy. We just have to look at the RL, right? So we'll see the RL. This is 4,000, this is 3,000, this is 2,000. So therefore, the ground is increasing along this way. Then we see here 5,000, 6,000, 7,000, 8,000, 9,000, like this. The ground is increasing here. So we have a peak over here. Maybe we have a peak over here also. The values are not given here for clarity. That's all right. So here also we see that the ground is increasing. So along this way we have a hill, and then in this side we have a bigger hill. Okay, this one is a peak. Like that we have to understand. Okay, and these are low-lying areas. Okay. So from here, if we say that we have to construct a road through this, so we will know that we have to construct it somewhere here through the low-lying areas, through the area which is little relatively plain, that way. Again, simple example, we have a hill, the RL is increasing, so therefore we must have a hill. Then again, this one. How do you know this is uphill? How do you know this is downhill? Because this is RL. Again, same thing. 300 is RL. The RL is decreasing here. We are not writing the values, but we are writing here 200. So we will assume that the RL is decreasing along this way, right? Okay, one or two maybe higher or lower, doesn't matter. But ultimately, what is happening? The ground is decreasing this way. So we have, in this side, we have uphill. And in this side we have downhill. So we have a ridge like this along this way. Okay. Then if we see something like this, again we have to understand, okay, here we have hill, here we have peak, and in between we have this saddle. Okay. Then The property of contour line is that it is never going to intersect each other, only except in only in the case of overhanging cliff. What is an overhanging cliff? This is a vertical cliff. Overhanging cliff will be like this. So because it is a vertical cliff, okay, at the same location the RL is increasing, right? So we are in the same location and the RL values are changing. So this may be 60, the other may be 70, next one may be 80, next one may be 100, like this, right? So that's fine. They are at different location at other positions, but here at the location of the vertical cliff, they all are coming together and forming a single line. Why? Because this is a vertical cliff. The RL is changing vertically at the same location. If we look from the top in a 2D map, in a plan, the RL is changing here. So this is an important property of the contour lines. Now this is an overhanging cliff. So in case of overhanging cliff only, what will happen? The RL may intersect, because at this location, what is happening? At this location, the RL is higher like this, and then again here RL is lower like this, right? So they are intersecting each other. So only in case of overhanging cliff, the contour lines will intersect each other. In no other case, it will intersect. In case of vertical cliff, they will form a single line, and in case of overhanging cliff, they will intersect. In all other cases, they will be separate. So again, another map. Again, from this type of map, what we have to know, where the ground is higher, we see the RL. Okay, these are RLs. Along this, we have a peak. Here also, we see, here we have a peak. All the data are not given, just for uh, example, we are taking this one. Okay, so the process is that this kind of map, what we are doing, we are adding other informations. Okay, now this is for contours. Fine. Now here we are adding other information like what is the vegetation cover. We can draw a, from the same concept of contour lines and contour maps, we can draw maps where we can show, okay, along this region we have this thickness of forestry, along this we have lesser forest. Okay, that type of map. Here we have mineral resources, higher density of mineral resources. Somewhere else we have lesser mineral resources. Or we can show population, we can show population density, we can show houses, buildings constructed. So all these things that we are now doing are have started from this concept only, fine. So this is very basic thing. We no longer need to do exactly like this. We have advanced techniques, right? We have GPS, we can have 3D maps, and we can incorporate data on the 3D map. But this has not been obsolete, but we have more information now, more methods available now with the advent of GPS, GIS technologies, right? So with those, what we do, we map together. Okay, we combine maps. One map we have just the features, just the area, just the plan we have, and then we combine on that map some more data like population density, data like earthquake intensity, data like earthquake locations, data like forest, data like mineral. All those things are incorporated. Then we have a set of information, and from there we can do other types of planning. For those things we will again talk about in GPS and GIS when we will be discussing. Okay, so this is the basic thing of. Now I shared one note with you people. So this was a handwriting note. So if you have any trouble in finding out the handwritings, so do let me know. So here we have different concepts. Okay, So okay, where we were? Okay, contouring. We know that what is contouring. What is contour interval? Okay, so contour interval is the vertical distance between two consecutive contour lines. Okay, so in this case, what is the vertical distance between two contour intervals? 60 to 65, 70 to 75. So 5 unit may be meter. 5 meter is the vertical um, distance between two consecutive contour lines, right? So that is the contour interval. Then there will be one horizontal distance between 2 points on any consecutive contours. Then there will be what was then there will be horizontal distance between any 2 points. Okay, so these 2 points, if you go back here, these 2 points, okay, here and here, fine, this is 65 and this is 60. Vertical distance is fine, it is 5 meter, but there shall be one horizontal distance also, right, between these 2 points. So that horizontal distance is going to be your horizontal equivalent. Okay, that way these two are important properties. And then choice of contour interval, it will depend upon the nature of ground and purpose of the map. Okay, so if the nature of the ground is steep, then the contour interval will be less. Obviously we have to know how it is changing, right? So So if the nature of the ground something like this, we have an overhanging cliff, just like we were discussing. So if the contour interval is very large, we are doing one contour, we are taking one contour here, and we are we are measuring another contour here. So what will happen? We will miss out this feature of the land. Okay, so it will depend upon how the land is, what is the extent of our work. Okay, then again, um, if the contour lines are very much spaced apart, okay, so what does it tell us? This is say for this is okay, this is 80, this is 100, this is 120, like this. And then another, we have another map we have where we are 80, then we have 100, then we have 120, like this. So the vertical distance is same in both the cases, 20 meter, 20 meter, 20 meter, but the horizontal distance is much smaller in this case. So what does it tell us? Here the ground is changing slowly, the slope of the ground is like this, but in this case the ground is changing quickly, the slope of the ground is like this. Things like that will come from the spacing of the contour lines. Okay, then scale of map, scale you already know, representative fraction, that is the scale. Smaller the scale, larger is the contour interval. Smaller scale means 1 is to 10,000, 1 is to 25,000, like this. Okay, so that is a smaller scale. So if that scale is very small, the contour interval has to be larger so that we can draw it properly, right? So that type of things. Okay, so please go through this note. Characteristics of contour lines, we already discussed, right? The contour line must close, not necessarily in the limit of the plan. So it's like this, right? We are studying a particular area, say for example, we're studying a particular area. The contour line must close, but not necessarily in our area. We can have a contour line like this. We can have another contour line like this. Okay, it is not closing in our study area, but in the actual field, it must close down. It must be something like this. It must be something like this. It must close down. Okay, that is one of the properties of the contour lines. Okay, widely spaced contour lines we already discussed. Closely spaced contour lines we discussed. Equally spaced, if it is, then we have an uniform slope. Okay, so what is uniform slope? Okay, the slope is same, it is changing in the same rate, so that is uniform slope. Somewhere it may be like this, it is changing. Okay, it may be like this. So if the distances are exactly same, then we will know, okay, we have a uniform slope. Okay, more or less, but the distances are not similar. Somewhere it is very small, then we will know, okay, this is steep. If it is spaced apart, we will know that, okay, this is little bit plain. Okay, like that. Okay, here the slope is less, here the slope is greater. That way we will come to know about the slopes. Okay, so that will be all. Just